Hello everyone, I'm Manmohan Alla. Today I'm presenting how organizations solve IoT skill challenges using Snowflake plus a structured feature store architecture to reduce cost while improving reliability, consistency, ML performance, and development agility. This approach comes from real developments, manufacturing, utilities, energy grids, and smart monitoring systems. We'll break down what problems exist, where pipelines fail, how feature stores solve them, and how Snowflake architecture brings performance and cost control that traditional systems cannot. Data explosion. The scale of IoT today is unprecedented. Many organizations think of IoT as just a sensor, but each sensor represents continuous telemetry streams. Manufacturing lines push vibration, temperature, torque, error logs, and many more, millions of readings per hour. Cities run environmental networks, power grids, traffic monitors, and more. Vehicle fleets push engine health, speed, GPS, weather, all streamed continuously. Traditional infrastructure was never built for this. So the challenge isn't just storing data, it's sustaining throughput while maintaining contextual meaning for ML. Three problems always show up. Number one, number of sensors readings per hour explodes, and pipelines must continuously consume them without pausing or buffering. Number two, these streams are continuous, so nothing ever stops. Ingestion must be always on, fault tolerant and incremental. Number three, heterogeneity, different sample rates, precision formats. When smart meters report every few seconds and vehicles report irregular bursts, you get temporal misalignment. And that breaks simple SQL analytics. You need infrastructure that can ingest, clean, normalize, model, and serve at streaming velocity. IoT data is meaningless without historical context. A vibration right now tells nothing unless compared to last hour or last week or sessional patterns. So ML features must include rolling window metrics, lag signals, trend acceleration, sessional behavior. This is where ad hoc scripts fall apart. Doing consistent temporal processing across thousands of sensors, across dozens of models, is impossible without structured, repeatable engineering. So the feature store becomes not a luxury, but a survival strategy. In many real deployments, over 70% of ML accuracy actually comes from temporal context, not the rod feeding. IoT data quality issues are unavoidable, like null values, network gaps, collaboration drifts, mainly noise. The danger is not bad data, it's inconsistent handling across tools, teams, and etc. Data engineers handle ingestion one way, scientists write manual transformations, operations team build PI aggregations. Result of all of it is same metrics computed three different ways. Models break when teams update independently. Reducing predictions become impossible. This fragmentation escalates cost and destroys trust. So what we do? We centralize transformations into a uniform feature store. In real world pipelines, I've consistently seen 3 to 6 copies of the same logic written by different teams because there is no centralized feature store. Feature store concept. A feature store fixes that fragmentation. Centralized repositories of canonical features, reusable definitions across multiple ML models. In practice, feature reuse cuts engineering effort by 60, 80%. Because once the logic exists, it automatically benefits every model. Versioning guarantee reproducibility. Optimized serving for low latency inference. Think about six teams building six pipelines to achieve something, but to create one pipeline for six teams. Snowflake architecture gives us a unique advantage IoT. Number one, variant enables ingestion of semi-structured JSON from sensors without schema gymnastics. Time travel means historical reproducibility. If data changed, models remain reproducible. Streams plus materialized views lets us do incremental change capture, meaning we only process new sensor data, not terabytes of history. Incremental updates routinely reduce compute load by 40-60% because you stop reprocessing historical data that hasn't changed. In short, Snowflake trades brute force processing for intelligent incremental work, and that's the core cost reducer. This architecture works at any scale because it's modular. Raw layer preserves truth, timestamps, device metadata. Transform layer performs all feature logic, windowing, smoothing, health metrics. Serving layer is denormalized for direct fast lookup by ML systems. This eliminates pipelines. Feature becomes software artifacts, not scattered scripts. This layered approach is how teams safely expand to hundreds of thousands sensors without rewriting pipelines every day. DBT turns analytics into maintainable software. Explicit dependency graphs, reusable macros for rolling statistics, or anomaly scores. Unit tests prevent data drift. I've seen automated DBT tests catching a huge amount of bad upstream sensor data long before it pollutes dashboards or models. Version control and code review. This enforces discipline. Every feature is testable, traceable, reproducible, and documented. That's how IoT ML can scale beyond pipelines to team infrastructure. SQL handles 80% of transformations. For the specialized 20%, spectral analysis, signal decomposition, anomaly scoring, Snowflake executes Python inside compute. This is critical because no data copied out of Snowflake, governance stays intact. Libraries like Pandas, SciPy, scikit-learn, available at scale. This gives us hybrid power. SQL speed with Python expressiveness. Isn't it great? This hybrid approach keeps SQL fast for bulk work while leveraging Python for about 20% of the cases that require signal processing, sophistication, cost optimization. We deliberately minimize cost. Compute is matched per tiny warehouse for simple aggressions, medium for wide joins, large only for parallel tasks. Matching workloads to warehouse size commonly yields 50% plus compute saving in production. Storage is tiered, granular for recent data, downsample for older, cold archive for compliance. Caching ensures repeated model lookups cause zero compute. Caching can eliminate nearly all cost for repeated lookups, especially for inference windows. Cost governance becomes architectural, not accidental. Performance patterns and trade-offs support multiple access patterns. Batch mode, perfect for ML training and mass scoring. Point lookups, acceptable latency but benefits from caching. Decentralized tables intentionally trade a bit of storage to enable blazing fast inference. In many deployments, denormalizing improves serving latency by 2 to 5x. In IoT ML, Latency predictability is more valuable than pure production operations and governance. Production means governance. Monitor data quality, drift, pipeline health. Monitoring feature drift is critical. I've seen unnoticed drift degraded model accuracy by 20 to 30% within a month. Access control via RBAC plus row security. Multiple feature versions active simultaneously. Cost tagging per model team to eliminate budget surprises. This creates a robust operational backbone supporting multiple IoT workloads safely. Real deployments, for example, in manufacturing, unified features improve accuracy and dropped engineering effort significantly. Smart buildings, data quality tests, caught failures before dashboards or ML models pull you decisions. Utility meters, Snowflake's columnar design plus clustering handled millions of customers at lower storage and lower latency. Bottom line, feature stores plus Snowflake, predictable costs and reliable insight. Key takeaway, start with access patterns. Architecture follows usage. Quality first mindset saves millions later. Modular transformations reduce risk and onboarding pain. Treat features as engineered assets, tested, versioned, governed. This is not a one off pipeline, it's a platform strategy. Treating features as engineered assets with tests, lineage, and reuse is what unlocks these gains. Typically 50 to 70% less engineering effort and noticeably higher ML reliability. So the key idea is consistency delivers both cost saving and accuracy. This approach scales whether you are handling thousands or millions of IoT signals. Thank you for listening. IoT data doesn't have to be chaotic or expensive. Structured feature engineering on Snowflake drives predictability, scalability, and trust. Happy to dive deeper or answer any questions. Please drop your questions in the forum and I can get back to you. Thank you.